Hello students, today we are going to talk about the topic heat capacity from calorimetry. Now before starting with the topic, if you want to improve and excel in maths and science, then do check out the courses offered by Infinity Learn and don't forget to use the coupon code HQ10 to get additional 10% discount on the courses. Now coming back to the topic, let us first try and understand what is the concept of heat. To understand heat, let us first talk about any substance. We know that all the substances are made up of molecules. Now these molecules are in a state of random motion, and because of this motion they have velocity, and because of this velocity they have kinetic energy. Also, these molecules exert force on other molecules, which is called as intermolecular force of attraction. And because of this force of attraction, they have potential energy as well. Now, if we add up these two energies of a particular molecule, that is nothing but the internal energy of a single molecule. And likewise, we have so many molecules in a particular substance, and if I add internal energies of all the molecules, then it is called the thermal energy of the substance. Now let us say I have a body which is relatively hot and there is another body which is relatively cold. So the hotter body will have a higher internal energy and a cold body will have a lower internal energy compared to hot body. Now when we bring these two bodies in contact, what happens is the internal energy of hot body reduces and it cools down. On the other hand, internal energy of the cold body increases and it gets heated or warms up. Thus we can say there is a flow of energy which is happening from hot body to cold body when they are in contact, and this energy which flows from hot body to cold body when they are kept in contact is nothing but heat energy or simply heat. So I hope we have understood what is heat energy or heat. It is nothing but the form of energy which flows from hot body to cold body when they are kept in contact. Now the measurement of quantity of heat is called as calorimetry, and the SI unit of heat is joule. There is one more famous unit of heat which is very often used. It is calorie. And if you ask what is the relation between joule and calorie, then 1 calorie is nearly 4.2 joules. Now there is a definition for 1 calorie also that we have over here. 1 calorie is the quantity of heat which is required to raise the temperature of 1 gram of water through 1 degree Celsius. Now calorie is basically a smaller unit. For higher values of heat we use kilocalorie, and 1 kilocalorie, as we all know, will be how much? 1000 calories. So if the same definition is asked, what is 1 kilocalorie, then the definition will be 1 kilocalorie is the quantity of heat required to raise the temperature of, instead of 1 gram, it will be 1 kg of water through 1 degree Celsius. And this kilocalorie wala part, it is mostly on all packaged food you will find value of energy written in terms of kilocalories. Next, let us talk about the concept of temperature. As we have already seen that if I keep a hot body in contact with a cold body, there is a flow of heat from hot body to a cold body. Now the body which is giving heat is basically said to have higher temperature compared to temperature of a cold body. Thus we can say that temperature basically defines the direction of flow of heat. So the direction of flow of heat is always from a substance having higher temperature to a substance having a lower temperature. Now when this cold body starts to receive heat, what happens internally is the atoms, the constituent elements of this substance, they start vibrating at a higher velocity, and thereby producing a higher temperature. Based on this, we can define what is temperature. So temperature is a parameter that basically first of all tells the thermal state of the body, which means how hot a body is or how cold a body is. Also, it determines the direction of flow of heat. As we said, if we have two bodies at different temperatures, so heat flows from body with higher temperature to body with lower temperature. Now, if in case there is no transfer of heat happening, if there is no transfer of heat happening, it simply means both the bodies are having same temperature. But please understand, this does not mean that they have same heat content. This we can understand with a simple example. We are able to heat some substances very easily, and with less amount of heat they reach to a higher temperature. On the other hand, there are substances which requires more heat to reach the same temperature. So if you have different metals, for example, or if you take two different materials, you will find that one will be reaching quickly to a particular temperature and the other one might be requiring more time. Now please understand, this is very important concept. So if I have a particular substance, two particular substances kept at room temperature, two different substances, and I want to raise their temperature by 10 degrees Celsius for both these substances. If you do this practically, you will find that out of these two, one will require relatively higher amount of heat compared to other to attain the same temperature. And therefore, if two bodies are having same temperature, that doesn't mean they have same amount of heat. Also, let us talk about the units. So SI unit of temperature is Kelvin, denoted by capital K. There is one more unit, degree Celsius, that is very widely used along with Kelvin. We also have a relation between temperature in Kelvin and temperature in Celsius. Temperature in Kelvin is basically 273 plus the temperature in Celsius. So if the temperature is 10 degrees Celsius, in Kelvin it will be 283 Kelvin. Also, if the temperature is 15 degrees Celsius, then the temperature in Kelvin will be 288 Kelvin. Now, if we look at these two examples, what do we find is the change in temperature on the Celsius scale is 5 and change in temperature on the Kelvin scale is also 5. So we can write change in temperature on Kelvin scale is equal to change in temperature. Delta T represents change in temperature on the Celsius scale. Next, let us talk about the factors affecting the quantity of heat that is absorbed. First thing that we have is mass of the body. So let us take an example where in a particular vessel I have water completely filled, and in the same type of vessel I have water half filled, and I want to heat them to the boiling point. Then obviously the amount of heat required in the first case will be more compared to the heat required in the second case, because यहाँ पे mass of water is more compared to the second case. So this is the first factor. Second factor is increase in temperature of the body. So if I want to increase the temperature by 5 degrees Celsius, then the amount of heat required will be less. If I want to increase the temperature by 20 degrees Celsius, the amount of heat will be high. Therefore, the increase in temperature of the body also defines how much heat is to be absorbed. And finally, the type of material. The type of material basically means is, if you have two different materials which are being heated, let us say one utensil has water and another vessel has some other liquid, then the amount of heat required to raise their temperature, let us say we are raising temperature of both the liquid by 5 degrees Celsius, we will find even though the quantity of material is same, the amount of heat required will be different in both the cases. So H1 won't be equal to H2, and this property is basically called as specific heat capacity, which tells us that some material may require higher amount of heat to gain the same temperature as compared to the other material, and it is denoted by small c. So over here what we have is the amount of heat absorbed, it is proportional to mass, and amount of heat absorbed is proportional to difference in temperature. So we have Q directly proportional M into delta T, and this proportionality sign, if we remove, we have this constant C, which is nothing but specific heat capacity, and it is the property of the material. Finally, let us quickly check out the differences between the heat and temperature. So first point that we have is heat is nothing but a form of energy which flows from hot body to cold body when they are in contact, and temperature basically defines in which direction the heat will flow if we have two bodies at different temperature. So basically it flows from body with higher temperature to body with lower temperature. SI unit is joule, as well as we have talked about calorie. यहाँ पे for temperature SI unit is Kelvin, degree Celsius, degree Fahrenheit. Amount of heat will depend on mass, temperature and the substance of the body as seen in the last slide. And यहाँ पे temperature depends on the average kinetic energy of the molecules due to their random motion. To measure heat, we use the principle of calorimetry, and to measure temperature, we use a very common device which is thermometer. Two bodies containing same amount of heat, they might differ in their temperature, and two bodies with same temperature may differ in the quantity of heat contained in them. Which simply means कि अगर दो बॉडी है उनका टेम्परेचर सेम है T1 T2, if T1 is equal to T2, that doesn't mean कि H1 will be equal to H2, and vice versa. अगर heat same है that doesn't mean कि उनका टेम्परेचर क्या रहेगा, सेम रहेगा. And finally, the total amount of heat of two bodies in contact is equal to the sum of the heat of individual bodies. So if I have two bodies, पहले वाले में heat है H1, second body has heat H2, so total heat will become H1 plus H2, combined heat of the two bodies. But if I have two bodies with different temperature T1 and T2, now they are allowed to exchange heat, then the resultant temperature will be somewhere in between the two temperatures. So let us say one was at 60 degrees Celsius and the other one was at 25 degrees Celsius. So the hotter body will cool down and the colder body will get warmed up, and maybe somewhere around 40-45 degrees Celsius they will be attaining a common temperature. So I hope it is clear to everyone the concept of heat as well as temperature. Thank you very much.